What we do in this panel discussion, we have basically we have 6 panelists, and they form 3 teams. I'm just going to ask them to come up to the podium one by one, and I'll introduce them very briefly to you. Many of them already gave a talk, not all of them. So we have 2 people from industry, we have 2 people from academia, and we have 2 clinicians, 2 radiologists. And they're going to discuss what I think, as a theme of this panel discussion, what do we need from each other? Do we agree with each other which way we should go, and where do we disagree? So let's start with the 2 representatives from industry. First one is Heinrich von Busch from Siemens. Give him a big applause. Just sit on the first chair. And Heinrich leads a very big group of researchers, developers in Siemens on artificial intelligence, I think especially on oncology, right? Right. Yeah. And the second representative from industry is not from one of these huge companies, but from actually 2 companies, but you have heard him speak before, so that's Tim Salimans. And then we have the people from academia. We'll put them in the middle. And the first one is also one of our keynote speakers, Graham Taylor from the University of Guelph. I find it difficult to pronounce, but Graham. And our second representative of academia is Hayit Greenspan from Tel Aviv University. But she is actually also heavily involved in industry. And I think this is an interesting topic now, right now. As an academic, you do not really count if you haven't started a company or something like that these days. And then we have the 2 representatives from the clinic. The first one we've already heard before, Ron Summers from the NIH. And then the last person to introduce, there I have to be careful because that's my boss, so I have to look out what I'm saying. But it's the head of the radiology department at Radboud UMC, Mathias Prokop. And he's a special kind of radiologist because when I was giving my inaugural lecture as a professor, I said that he was one of the few radiologists who would not get angry at me when I was saying that my goal is to replace him with a computer. And another thing that's special is Mathias also studied mathematics, so he might actually understand backpropagation, I'm not sure. So that is the panel. And we're going to also see if there's questions from the floor, but I want to start with something that is very obvious, because that is how Geoff Hinton put it in 2016, when he also was in such a panel discussion, and he made a statement which really has caused a lot of stir, I can tell you, in the world of radiology. He said people should stop training radiologists now, and that was because it was completely obvious that within 5 years, deep learning is going to do better than radiologists, because it's going to be able to obtain a lot more experience. So we only have 3 more years to go before deep learning is going to do better than radiologists in everything that they do, because we can stop training new radiologists. And I would like to ask if there's somebody in the panel who can say something whether this was a good or a bad idea of Hinton to make this statement.
I'll get the ball rolling on this one. I think what Professor Hinton said makes sense if you view the job of radiologists only to be pattern recognition engines. And I'm hopeful that we provide more added value to the patient than serving as a pattern recognition engine. We need to, in our job, do a lot more than just identify abnormalities and classify them, but to integrate all the information that we have about the patient so that we can provide the best diagnosis and a recommendation for treatment, or have discussions with clinicians about how best to help the patient. So I think that Professor Hinton's comment is certainly one that has stirred a lot of controversy, but I think it mainly focused on just that one aspect of our jobs.
I think his statement has made an impact. We do have problems now getting really, really good people. We see that the numbers are going down. And one thing that he's right about is that if you look at a clinician, it takes us 6 years to finish medical school, another 5 years to go through our specialty training. If you want to do a PhD, it takes us another 3 to 4 years. So to be good, you need to do another 3 years. So you end up somewhere between 10 and 20 years before you have someone who knows nothing to become a valuable clinical person. So if you look at that, starting from medical school, maybe he's right. We will probably not need the radiologist we have today. If you look on the short term, I think he runs into a problem that I have myself. I call it the pi or pi square problem. Usually when I predict the future, I'm too early, usually by a factor of pi if I'm lucky. And I'm not so lucky, it's pi square. I think he's probably going to be in the pi range. But there will be a point where these parts that you just said, the pattern recognition part, is taken over by machines for a large percentage. And if you look at what we're doing at the moment, we see our workload going up massively. If I look how I work when I do my clinical work in the last 20 years, I have become a pattern recognition engine for a lot of my time. I would call it the factory worker paradigm. We used to be people that would do a lot more with the patients and help our clinicians fine-tune their decisions. But since the workload has so much increased, we're now people that generate reports for a large part of our day. So I would like to get rid of that. So in other words, I'm looking forward to AI help me do that. But then I have to reinvent myself and see what we really can do in order to add value.
Okay, so I come from the point of trying to convince the radiologists that this is good, everything that we're doing. And I noticed at a few RSNAs that this statement of Hinton actually caused a lot of stress, and definitely for a year or more, people would come and say, are you going to replace me, in a very stressed mode and fearful mode. So in that sense, I was not very happy with this kind of a statement. Basically distanced us from the radiologists which we wanted to serve. Also, looking at learning more about what the radiologist is doing, and not being a radiologist myself, I realized that there is the two components, which are the detection and measurement, which you then write in the report, and then there's the diagnosis side of things. And when we analyzed and asked many, many radiologists, we came to the conclusion that 80% of the time, definitely agreeing with what you said, radiologists do the first two, which is the detection and measurement. And then only 20% of the time, or maybe you'll say even less, you have to really take all that information in and diagnose and do more global analysis and really provide a lot of insight and understanding of the case. So definitely I think that we have a role in helping in the first two, which is the detection and measurement. And I've heard that that would definitely be acceptable and of interest.
I think what I can add to the previous discussion is maybe a book recommendation by a colleague of mine in Toronto, a number of colleagues, Ajay Agrawal and Joshua Gans and Avi Goldfarb. And the book is Prediction Machine. So it's a book for on the advances in AI and machine learning for a general audience. And in that book, it does a very nice analysis on not just radiology, but this general question of how AI will impact the nature of work. And I think something this book writes about that's already been brought up is that jobs are made up not of a single task, but thousands of tasks. And I think certainly AI and machine learning systems will replace individual tasks in those jobs and change the nature of work. So jobs themselves are going to change, but we'll probably see less job elimination. But those jobs that will, I think, become more relevant are those that contain a diversity of tasks, like the ones radiologists do right now. So I think overall, certainly I agree with, we'll probably be changing the way that we train doctors and train people in other professions and adapt to the changing nature of their work.
I would love to provide some of the fireworks that Bram requested, but I'm actually totally in agreement with the previous speakers. I think if you look at automation, sometimes it replaces jobs, but mostly just changes them. So apparently, after the ATM was introduced, you actually got more bank tellers rather than less. But the thing that actually the services they provided changed, and they started adding more value in different ways than just taking cash out of the bank. And I think the same is going to happen in radiology. So during my work with Aidence, I've met a number of radiologists. Some of them are really open to this idea, and they're willing to think with us on how radiology should look in the future. And others are kind of scared of this, and they're not willing to engage in the conversation. So what I'm hoping to get out of conferences like this is to really open up the dialogue, and I think we're making great progress there.
Yeah, in the vein of what has been said before, it's well known that the workload on radiologists rises much faster than the number of radiologists rises. So in a way, I guess it's inevitable that there will be tools that increase the productivity and actually take off the workload of the more tedious tasks off the shoulders of the radiologists. And I think one very nice statement that I would like to quote is from Dr. Padani, who said, AI will allow us radiologists to become doctors again.
Okay, so this sounds very beautiful, and I like that. We're not having fireworks yet. So let's go to the next slide, because I heard people say also in deep learning, supervised classification, that's solved. That's the most boring thing to work on now. We should work on, I don't know, agents, guns, whatever. But we have been working on Hinton's agenda. In fact, we only have 3 more years to go. There is some software now, but in the clinic, all these images are still read by humans. And people have started to predict the next AI winter, with more focus on self-driving cars that were announced, but are still not there. Where are the tools that will make the life of radiologists better? Why are they not there yet? What is making this so difficult to implement? Because you're still doing all your measurements manually, right? And it's not beyond the stage of I show promising work, which I will present at the next MICI, like Ron said. Maybe you, from big industry point of view, can give a comment on that. Why don't we have the tools yet?
I think when we look at what the tools can do and how they can usefully be trained, what we see is that in many cases it's a very well-defined, very limited, very confined clinical question that can be addressed, and it's actually quite a bit of work to even just cover that one clinical question. So we will see the development starting with point solutions that address certain areas, but there will be huge gaps in between, and I think what we will see over time is that these gaps will be growing over with further solutions. So I don't think it's reasonable to expect that everything will be there at once. It will start with the more tedious tasks, with localization, with segmentation. For instance, when you look at the preparation of radiotherapy planning, people spend a lot of time just segmenting not just the target that you want to hit, but also the organs at risk that you would like to avoid. Those will be the tasks that I think will be the first to be taken over by automated solutions.
So I think there's a large divide between the world of bits, the internet companies, and the more classical applications, or the more classical jobs like medicine. Speaking about AI more generally, I think it's quite clear that AI is actually already providing lots of value to the big companies like Google, Facebook, Amazon. And it's somewhat slower to work its way to some of these other areas. One reason is regulation. So people like Tyler Cohen and Peter Thiel have written about this a lot. Their claim is that one of the reasons that innovation seems to have been almost only confined to the world of bits so far in the last couple of years, is that it's just much easier to innovate there. You can quickly iterate on your ideas, and you don't have to go through very long sales cycles or deal with different difficult regulators. And this is also a problem that we have encountered in practice. It just building a medical product takes a lot more time than building a photo app. Yeah, for good reasons to a large extent, but also for some reasons where we could make improvements as a field, I feel. And yeah, I'm still hopeful that as AI matures as a technology, then all the systems around it will also learn how to adapt and how to accommodate it more easily.
So first on optimism and my response to this, I think about a year ago, I started noticing with each update on my Android phone that the machine learning provided services were getting better. And that was actually noticeable. So the predictive text, when I was typing, the speech recognition, and I'd never noticed up to that point that these improvements were so obvious. And so that's, again, going to what Tim said, on one side with the products being developed by the internet giants, it's quite obvious to me that there's still a ways to go and that things are still accelerating in terms of the technological improvements. I'll offer another suggestion on one of the reasons why the application scope hasn't increased as much as we'd like to expect. And I think that, for me, it's about time scale. So some of you probably, or many of you are familiar with the AlphaGo system that AlphaGo 0 announced in last fall was able to beat the best machine or human Go player in just training by 3 days, was entirely self-play. And it's actually amazing algorithmic achievement, but it's able to do that because it takes a fraction of a second to play a game. So that's why it can play 2.4 million games in 3 days. But problems like health and agriculture is another one that I think about a lot, have much different time scales. So you can't get an observation or response in a fraction of a second. You need a growing season, or you need a course of treatment. And I think simulators might be, in other words, generative models and so forth might be a way out of that. But I think it's not the only solution, and I think we'll be tackling that for some time.
Okay, so putting my academic hat on, I think we enjoy looking at problems, and we usually look at the ones that we have data for, like in a challenge, which is a great tool for us. So we would use the data that we have to try and develop new methodologies, variations on existing networks, anything that we feel like that would get published. Or we have a deadline for a conference, right? So we have to go very fast. So these are the motivations on how we work in the academic environment, which leads to the fact that we are generating great algorithms, very sporadic kind of applications, and we don't really build our academic methodologies on real needs, but rather on what we want to research. So each one of us is doing what we want to do. And I saw a totally different perspective when I started being included, thinking about a company level where we want to really sell and provide help and support to the radiologist. And once we take that step and look from that perspective, the first thing you do is you ask, okay, you, the radiologist, what do you need? And very quickly it became evident to me that if we want to provide a tool to support them, when we show them one thing, they want one finger, they want the hand, and we show the hand, they want the whole body. So if we show them, oh yeah, we can find something in the brain, or they, oh great, can you find a fracture in the spine? And can you do this here? And oh, that's a great idea, let's do, so each one has their own needs. And I think that leads to the idea of packages, like we need multiple apps. First of all, we need to start orienting our research to real needs, and then we're going to have to bring this to the real use, we're going to have to try talking about packages, so that of what we can call apps. Okay, so each one, now there's another barrier here, and that is that we used to publish things with a certain percent of accuracy, but if we want to really provide support and be used, then we have to think about things like false positives, very, very, very low false positives, so that we don't take more time, but rather save time, and so on. So a lot of our thinking and designing of our academic research is not necessarily oriented correctly towards what can be very fast adopted in the industry. So I think what I see now in the industry, I see marketplaces coming out and all sorts of other kind of names for, let's take a lot of these different algorithms and put them together. And that's sort of what we're going to have to do to really make a difference. So several ways of thinking about it. Basically, each one of our algorithms needs to be very, very strong in performance. And now we're also talking about false positives, so that's great. And then to translate, we're going to need to think about packaging them into multiple. And who's going to do that? It's either the small company, the large company, the PAC system, the reporting system.
Some kind of platform war is developing, right? Is there anybody in the audience who wants to ask a question on this? Tim, over there.
Thanks very much for this interesting panel discussion. So I'm a radiologist, and I can tell you I'm very much looking forward to getting some of the tools that were shown here in my hands to deliver better patient care. But I think a couple of observations. I'm not afraid at all of my job, because I very much doubt, and I would like to hear the panel's opinion about that the companies are willing to take liability for wrong diagnosis of AI algorithms and software. So that's a first barrier that I see to completely replacing what I do on a day-to-day basis. And the second thing that hasn't been mentioned yet is, what about the ethics part of this? What if we design this fancy algorithm that tells you this cancer patient should not be getting this chemotherapy treatment? How are we going to deal with that? I think this is an important question to answer before we start relying on these things. Yeah. And the other thing is the safety aspect, of course. How do we deal with that?
Let's wrap that all in one question.
Okay.
Anybody?
So that covers questions that span a wide range of scales, and I think scale is a very important thing to think about in developing these systems, because AI systems can operate at different scales, from the level of automated segmentations where you would just get measurements all the way up to full-blown automated detection and diagnosis. So as the other speakers have mentioned, there are potential success stories in developing systems that apply artificial intelligence at lower levels, and I frankly don't see why those things aren't available today. They work well, and they could be easily disseminated. The concerns often are raised about the more advanced types of AI, which are making recommendations about treatment and diagnosis. And we have a long history in radiology, for example, of systems that do just that. There have been mammography computer-aided diagnosis systems for probably 2 decades. There are algorithms, perhaps not computer-based, that physicians use to make decisions about how to treat patients. So I think ultimately the physician will be making the decision about how to treat the patient, and these algorithms will be there to help the physician. So I think many of the ethical and legal issues that were brought up in the question, we've already seen versions of those questions being asked about existing systems that perhaps we haven't called artificial intelligence, but which are some sort of computer algorithm that is helping physicians make decisions. So these aren't new questions. Many of them have been addressed both through the legal frameworks that have arisen over the years, and similarly, the ethical questions have I wouldn't say they've been fully addressed. Obviously, there will continue to be ethical questions asked about some of these technologies.
George?
Just to try to kick in a little bit the fireworks. So if I try to act as devil's advocate, if we can categorically show that an algorithm can, in average, perform better than a human rater, isn't it unethical to allow humans to diagnose patients?
That's not enough. Now, there's one point, if you look at the classical performance of CAD algorithms in our field. The classic was you would have a resident in training, then you'd have the CAD, then comes the radiologist, and then if you combine CAD plus radiologist or CAD plus resident, you get a similar high performance. That was how the field was moving the last 10 years, plus minus. Now in the last years, you see now suddenly algorithms that do differently, where you have the resident, you have the radiologist, and then you have the CAD system. But as soon as the radiologist interferes, it becomes worse. At that point, the ethical question is easy to answer, that radiologists should not actually act there. But we had, during this session here, the issue about how secure is the system in making this prediction. Because you train it with a certain amount of cases, but in real life you have cases that are way out of the training data set. So you will have to have some human interaction to look at those. If it can be detected automatically, great. But then I don't see it as a legal or a moral thing. The problem is who takes the liability. But again, what we see, if you look at the legal issues in the US, mainly where liability is a big, big issue, if a doctor misses something, it doesn't automatically mean he hangs. That used to be the case in the 80s and 90s. Now it is looked as, would he normally have to have seen it? Or does a large percentage of his peers also have a chance of missing it? If that's the case, he doesn't hang. So if you have systems that perform like that, I think there is no legal and no ethical reason not to do it. The problem is getting through the FDA and the EMEA and all the other regulatory approval
Then let me maybe frame the same question slightly differently. I think I have a lot of questions on this slide, and one of them is similar. So I think you have already said that there are useful algorithms for medical data today, very good algorithms that analyze mammograms, for example. Shouldn't we say, in Europe, where now GDPR has been installed, patients have the right to get all their medical data for free? According to the new regulation, how hospitals are going to provide it is a second thing. Shouldn't they have the right to have your scans processed by the best software? Maybe even for free, because the software is there. For radiologists, we can say it takes too much time and money to train them, but the software is available.
What is the best software? And there you end up again in good testing data sets that are generally accepted, that span the right range. So there are a couple of little issues that need to be solved before you can say that. But in principle, you'd like to open that up, but you can already do that. Now, as a patient, I can say, okay, I want to come to Zebra and let them just look at my images. No big deal.
It's not so easy, I would say, for the average patient.
No, the question is that there is no system in place that makes it easy. That's the point. And if you look at the clinical applications, one of the biggest issues I see in AI is that we radiologists, each of us, has their own little things that we find interesting. So if you talk to many radiologists, you will get many, many different answers that are important. But the real question is, which are the game changers? Which are the things where we really need help, where this help would make our business model more effective? And there we really do not agree. And a lot of the solutions we have here are point solutions that are not enough. And these point solutions are nice to have, but they are not essential.
Okay, well, we've talked about quite a few things here, but I can tell you one thing from my experience is that we take an algorithm from an academic environment, and we see in the paper that it reaches a very nice percentage of performance, and then we start getting more data from a hospital and then another hospital. and you see that the performance drops. So one of the reasons things are not out there yet is because we have not proven ourselves yet in real-world environments, which is, I mean, you can think about the automated driving, right? For some reason, people are willing to get cars fully automated on the roads now. I don't have any clue as to why. And every once in a while, there's going to be a problem with that, right? Well, we have, I think in all of our different algorithms, we've seen less data than we would like to see, and we've trained as much as we could. But now we have to go out to the real environment, and we're not there yet. So somehow, I mean, the data issue, the data problem is a very, very big barrier for us to get really going here. Definitely an issue that we have to deal with.
I think we don't know if we are not there yet for certain applications,
okay.
but that's...
Yeah, definitely. So one of the solutions that we had, so I'm coming from the company I work with and so it's called RedLogix. And RedLogix, what we do is a virtual resident. So in order to avoid these issues right now of concern by the radiologists and legal issues and so on, we're actually trying to be the resident. Okay, so we're just the resident, and following the first initial report that we provide, the radiologist, just as he's working today, will need to sit down, review it, and sign it off. So I think that would answer quite a few of the issues that came up. And that's just one idea of how we can work with this, at least initially. Because yes, I think these algorithms will go and help also in the diagnosis, and provide more diagnosis support. But for now, with the detection and measurements and so on, just to start putting us in the field, that's one approach that we can take.
So to add a little bit about the problem of certain techniques not carrying over to new data sets that are slightly different. I think this is definitely true for much of the research that you might encounter, but when you actually build a product, the demands that are being put on that are actually a lot more strict. So the regulating agencies, they actually do ask you to show that when you do have a different type of data set that you haven't trained on, whether it still works. And I think that's fair, and as long as we can show that the things that we use in practice actually do generalize properly and that they do reach the level that we would require of a high-level clinical practitioner, then I think the safety aspect should really be a non-issue at that point, as long as you have the data. And then as far as the ethical concern goes, personally, I would actually be much more comfortable with knowing exactly what pieces of information went into the advice that my doctor is giving me, rather than potentially be some complicated function of what I ask of the doctor and which particular doctor I speak to. And if we could standardize this a little bit, I think it would be much easier for us to guarantee that everyone gets a certain level of care and that we're consistent in our decisions. And I think if you combine this with the human judgment, it's going to be a strict improvement.
Max?
So we haven't mentioned the factor of trust, and I think this is very important. So, and I see a question here about explainable AI. So I think explainable AI will probably help us bridge to create more trust. But one question I have is, when these systems become more and more complicated, can you still even explain them? And will this be, will this be a problem for a radiologist if the system is very good, apparently, but it can't explain itself at all? Will you still trust it?
A couple of things I would say on that, because we've been talking a lot about explainable AI in my lab, is one issue is the definition of explainability, and I don't think we have a great definition right now. I think the other issue too is we often point to people as examples of explainable systems, but they're not either, as Tim mentioned. So those are the two issues that I have with explainable AI. Even though we're working on sort of algorithmic ways of interpretability, but I don't think we've yet hit explainability for those reasons.
Do you know exactly how an MRI scanner works? And yet I bet you'd be willing to get into it and have your images obtained.
So you don't have to convince me, because I'm with Tim. I will just gladly be analyzed by an algorithm, but I wonder about doctors, how they and radiologists, how would they look at this?
I think it's easy to criticize algorithms for lack of explainability when they're deficient at making their predictions in the first place. Once the algorithms become excellent at providing recommendations, I think the question of explainability will move to the background.
Well, I think it's by law now in Europe, it has to be explainable, right? So,
But that's a very interesting comment, actually, that it will
think
go
that
away.
I totally agree there. If you look at how we do that intuitively, we are humans, and it's a little bit what all of us are doing. We are, it's heuristic reasoning, basically. Let's say we have an algorithm that detects lung nodules. It takes all these small, difficult nodules for us to find, which most of them are absolutely irrelevant because the big ones are important. And the big ones it misses because the algorithm hasn't been trained to detect big ones. Then our heuristic reasoning will tell me this is a crappy algorithm. I don't trust it. But if all the things I detect, this algorithm detects, and it shows me 2 or 3 others that I haven't detected, then I trust it. And I don't have to know why that is the case. I only will ask myself, why didn't it detect the big one? That's when I ask myself why. But if it works, the why is no longer important.
And this is true for all the radiologists, because the fact that you're here means you have probably a bit of a progressive opinion about this.
I like to think of myself as progressive. Radiologists differ one to another just as people differ one to another and have different ways of coming to their opinions. But I think what I said is true in general. If the system, and as you mentioned, if the system is highly functional and provides useful predictions, does it really matter how it works? I mean, do we really understand how our brains work, and yet we all depend
on them, right?
we all depend on our brains to make every decision every moment of our lives. So understanding I think comes from systems that don't work properly and being concerned about when they're going to fail. Isn't that the crux of the matter? We need to understand a system when we're worried about it failing and how to repair it.
I think, as usual, we're running out of time in these panel discussions. There's one other different topic that I would like to end with. That's the one that these days the best talent in academia is bought by industry. Is this true in Europe? Is it a problem? Okay, that's a difficult question. Yeah, so it's a bit related to this cry from the Alice Initiative, saying that we're really in trouble in Europe. Europe is not keeping up. Most of the top labs, as well as the top places to do a PhD, are located in North America, massive investments in China, and we need to really do something to secure academic research, particularly in Europe. What do people think about that?
I mean, the question is a little bit insulting because it's like, for those of us who choose to remain in academics, I guess that means we're not the best, but but I think there are some of us who really enjoy working in academics. It's actually as an academic, one of the questions I get asked the most is, why haven't you jumped ship? I mean, for me, I really enjoy the university environment, and I really like working with students. And I think the students are the future, and they're the ones that are being hired to these companies. So I've heard it argued both ways. I've heard that by taking some senior academics away from universities, that funding goes to university to hire more junior professors. So that's one way it could work. But I think we'll always have people who, like me, enjoy the academic environment and enjoy the freedom that's associated with academia. And I think also we can work with industry. So we do a number of different industry projects. So you don't really have to choose one or the other. That's my opinion.
So then it's not a problem. We all think this is not a problem. I like it that finally my PhD students now stay in the field, start to work at a company, in some cases earn more money right after their PhD than I earn right now. This has never happened before, and I think it's very nice.
I think it is a problem. I just don't know where we're going exactly and how we're going to solve it. I mean, I think things are changing, and they're changing very, very fast. Many of my colleagues in the US are, in fact, in industry. Professors that are now hired or handpicked out to the industry. We see that also in Tel Aviv, that's happening. And I see other colleagues, mainly from the US, I'm not so familiar here, that are picked now to China. So, and these are both professors and highly ranked researchers in industry, research industry. So, I mean, things are changing, and I don't know if we are aware yet on the scope of this and where it's heading. So I think one thing I do see is that there's a lot of effort to work on combining industry with academics. And so one direction we can think of is how do we do things jointly? And I think one direction is the following. Industry needs academics to get new people, new talent. So we are responsible in academic environment to educate and get the new generation going, and going very fast. And in order to get this new generation out to the industry, we need a lot of support and a lot of funds. So I think industry needs to take part in supporting this, really hiring more faculty, getting more students, getting a lot of GPUs to the universities, and just getting this ball rolling. So I think there's a lot of joint effort now that should be done, industry and academics.
Good. Heinrich, and then following from the audience.
Yeah, I would like to second that. So I think the underlying assumption of the thesis is actually a double-edged insult, because it sounds as if industry was a black hole and basically all this great talent was lost forever. I guess everyone would like in the end to see good products, and for that, of course, talented people will be required. So I think that's the one point that I would like to make, and the other is to support what you just said. Collaboration is the key. I think there is a role for industry, there is a role for academia, there is a role for the clinicians, and if we work together, then we can actually make the difference.
So just a quick point. It actually was identified as a problem in Canada, mostly by Yoshua Bengio and his colleagues. And one of the things that CFAR does, in addition to running these, blue sky research networks like Learning on Machines and Brains, is we were also given a responsibility for something called the Pan-Canadian, with apologies, artificial intelligence strategy rather than deep learning strategy. Graham is involved in this. He wears many hats, but the three institutes that were established in Canada, Vector, Mila, and Amy, are independent of the universities. And speaking as a former university administrator, I'm not underestimating the challenge of that. But the reason for the independence is it addresses the issue that you've raised about your students making more than you are. The so-called CFAR Canada AI chairs allow for a supplement to salary. And the quid pro quo is that anybody, even if they're full-time industry people who aren't allowed a supplement to salary, they must participate in a strong way in the research of the institute and in graduate student training and in student training in general.
Yep.
And so that's one way around the problem. I encourage the Europeans to look into that.
Yep.
It's not a huge investment of money, but it's critical that the institutes be independent so they have this freedom of making special negotiations with the professors.
Yeah, and I think the Alice initiative, I invite everybody to read the whole letter, is to a large extent inspired by what you've done in Canada.
Yes, maybe I should say also something, because I was one of the people who wrote that sentence there. And I actually think that I agree it is a problem. So on the first, I have now an opening for a full professor in machine learning, which looks like a really attractive position, and it's really hard to get good people into that position. At the same time, we have massive amounts of students applying to the department, and they all need to be educated, and it's really difficult to find the people to do that. So I think there's quite clear evidence that this is a problem. I also think there's a solution, and the solution is to get the companies more involved into education to make them part of the ecosystem, which means that, you know, come teach a course or fund research or get involved.
Get out of the black hole.
Yeah, well, I think some of the companies are doing that, and that's fine. But and also for, you know, we should offer more flexible positions, which means half in academia, half in industry, and sort of get a better salary, and at the same time also work with students. So I think there is solutions to this problem, but we will have to work at it.
George, your closing remarks, because it's lunchtime.
That was so we've been talking about students and we talk about academics, but I think there's the other gap, which is the postdocs and research associates and etc. And I think there's a lot of research happening in universities, very big research that can happen in universities and probably will likely only happen in universities, that is actually is much more prone to this kind of danger. So PhD students need training, and they will go through the training phase, and maybe they'll move to industry. And then you have academics, which already have a permanent position, but they might stay. But postdocs are actually the ones that are in the tricky position, because they have the training, and they need to be altruistic and want to stay in academia to some degree. And I actually think that that's very dangerous in many ways, because it restricts the length of research that people do in university. It means that you have a 3-year vision or a 4-year vision for a student. And it doesn't allow universities to build large visions and large infrastructures, because for that you actually need postdocs. So I think there is a third. I would like to know your opinion on this third view of what happens with university research when postdoctoral level students or people start moving to industry, because it does impact a completely different type of science, I think.
So I totally agree with you as well. And just to add to John Hepburn from CFAR's comments, because he mentioned the support for faculty to retain faculty, but also part of the Pan-Canadian Artificial Intelligence Strategy is support for more postdocs. So it actually, their salaries would be more at the level of an industry salary, and also providing, beyond salaries, the other supports that researchers need: computational resources, software engineers. These are the kinds of resources that the large industry labs have. And that strategy, I don't know the details of Ellis, but I imagine there's, along those lines, those kinds of resources are being made available to be competitive in the postdoc space as well.
Okay, that's a positive note to end and go for lunch. I would like to thank everybody in the panel.